Hi, ever felt like learning Python is too complicated, too slow, or just not beginner friendly? What if I told you that in just 1 hour you could understand Python clearly and start coding right away? Hi, I'm Dr. Zeeshan Bhatti. Welcome to Learn with W3Schools. In this course, we're going to dive into Python using the simplest and most trusted platform out there, the W3Schools website. We will cover all essential topics, including variables, data types, conditions, loops, functions, lists, dictionaries, and much more, up to 20 key concepts within just 1 hour, 60 minutes. Well, in this course, we skip the fluff and focus only on what matters. I will walk you through the entire W3 Schools Python materials step by step, explaining each concept in plain English with live examples and codes and walkthrough. By the end of this hour, you will be writing real Python code with confidence and absolute clarity. So grab your laptops, open W3 Schools website, navigate to Python's tutorial, and let's start learning Python the smart way. With me, Dr. Zeeshan Bhatti, right here on Learn with W3 Schools. What are you waiting for? Let's begin. Okay, so first thing we do is head on to the W3 Schools website, and it has a wonderful interface. Just click on the Python tutorial here, and this will load up our Python course. Okay, now introduction to Python. This is the entire Python course that we're going to be covering. Try to cover as much as we can within this 1 hour. So first, why we learn Python? Python is a popular language, a programming language. It can be used on server to create web applications, but this is very understatement. You can do tons of things with Python. Let's go into introduction. Why we use Python? Well, Python can be used for web development. Python can be used for software development. It can be used for mathematics, analysis, AI, data analytics, anything that you want to do nowadays with the system in the computers. Python is there for you. For every automation, for every data analysis, Python is there. So these are just few things that listed here, but again, the list can go on forever. What Pythons can do, Python can be used on server to create web applications. It can be used alongside softwares to create workflows. It can connect to your databases, handle big data, rapid prototyping, production ready software development, everything you can nowadays do with Python. Okay, why Python? Why we need Python? Well, according to W3 Schools, Python works on various different platforms. Okay, so that's one major thing that is quite important for us, that whatever code you write, you can run, recompile and run the code on almost every single interface on software operating systems. The syntax wise is quite simple, easier to learn and follow. It usually basically uses English language in direct way. Python has a syntax that allows developers to write programs. It runs on interpreter based systems, so that's a key thing. It uses interpreter based systems, means the code is executed line by line. Compiler based systems are softwares that actually you write the whole code, you compile entire code, and then based on that the code is generated. Python generates a bytecode based on interpreter system. Line by line code is executed. Finally, bytecode is generated, then it's executed on your system. Again, good to know. The basic few things again are here. The key thing to remember is that we are using the latest version Python 3 version is going to be used here. So let's just get started with it. Again, enough theory already. Now you need to install Python. In order to do that, you need to go into python.org website and click on downloads to download the Python SDK. So make sure you download it and install it. Just installation is quite simple. Next, and that's done. Then you can configure it in VS Code as well. In order to configure them inside the VS Code, make sure you come here into the extensions and type in Python. And there are few extensions that are required for VS Code to be able to run Python. First one is the Python itself. So click on this install. I already have it installed. Click on Python environment. That's quite important, especially if I'm using in Mac. You need it if you are using in Windows. Usually Python's environment variables automatically installed, so you might not need it, but it's a good thing to install it. And then Python debugger will also be installed automatically. I also have installed Python extension pack. Again, I have a detailed tutorial on how to install Python in your systems. Check it out in the link below. Finally, I do have a code runner that gives you this play button, so you can type in the code, save it as a play file, come here and execute the code, and it will run and execute the code here. Okay, so this is one way of doing it. But since we are using W3 Schools website, W3 Schools has a wonderful interface where you can directly type in Python without having the need to install it. So that's one other reason for using W3 Schools. So if you click on try it out, you can see this, the Python code is there. You can run it here. You can type whatever you write. Click on the run code and output will be shown here. In this tutorial, we're going to be using this entirely. Okay, we're going to be using this W3 Schools built-in Python editor to run our code. So that should cover the basics of it. Next, syntax. Now, what do we mean by Python syntax? So according to W3Schools session, executing, or what we have learned previously, is that the basic Python is we write the print statement. When you execute it, it prints the hello world. Okay, so that's how the basic syntax goes. Okay, so for Python, you don't need to write any other header file for now, and then there's no void main required or any other thing. You just start writing the code. That's it. Simply, no brackets, no fluff, nothing. You start writing the code, and that's all its basic syntax is. Okay, second, the key thing to pin within Python to remember is indentation. We're going to talk about indentation throughout all these topics, because within Python, indentation is quite important. What do we mean by indentation? Indentation means that Python requires a block of code. In other languages, if I tried yourself, for example, in other languages, we use the curly brackets. So if you come here and close this is a block of code. In Java, C++, C# representing block of code. In Python, there is no block of code. There's actually indentation. By indenting the code, we identify that this print statement belongs to this if block. If I remove the indentation, now it will generate an error, because now it doesn't understand that this is a block of code or not, because there is no indentation here. So that's what we mean by indentation. To be a part of a block or part of another statement, a sub-statement, you make sure there's an indentation. A single space would do the trick, two spaces would do the trick, three spaces would do the trick. At least there's one space for that indentation. That's what basically this is talking about. So if you remove the space, this will generate an error. Similarly, if you have multiple ifs, this is a separate if statement. If you execute the code to test what's happening here, you see both lines are perfect. So it doesn't really matter, because this if is concerned with this block, this if is concerned with this block. So you can have one space or five spaces. At this moment, doesn't really matter, as long as there's no second statement. So for example, I have another statement here, and then I type in, for example, hello, second print. Okay, so now what happens is that now you have to make sure that both of these lines have the same indentation. If I run the code, you would see that I have a hello world printed, no problem, no error. But now if I add one more space here, this will create an error, because now indentation is different. This has one indent, this has three indents. So now Python will get confused. So if I run the code, it will say, hey, what you are trying to do here? And it will generate a long error for us. So in Python, indentation is quite important, and we try to match the indentation of our parent. Means that this is my parent, and that both childs need to be on the same indentation. So this is another parent, and it has a different indentation. So if I write another statement here, Control C, I have to make sure I match the indentation. If there's a difference in indentation, this will generate an error. I have to start below it in the same line. So this is key point that we follow. This is the most important and irritating part of Python itself. Honestly, it irritates sometimes a lot. If your indentation is quite off, it will give us errors. Okay. Second, Python variables. The basic syntax of variables are, again, we're going to talk a little bit more about variables later on, but Python variables are basically just the variable names. You don't need to specify any data type before it. By variable means these are variables that store some value, and then you can use those values later on. So if you execute the code, what's happening here is that we've created a variable. It's like a container. It holds the value 5. So what happens when you create a variable, a memory is allocated, and inside that memory, a variable 5 is stored. So when we have 5 or y is equals to hello world, this means that a memory has been allocated inside our system, and that memory now holds this hello world data. And to access this memory, we need to use this variable 5. And so to reuse this variable, now we can say, hey, print the value of y, which basically means I want to print the value of this hello world here. I can say print the value of x, which means I'm going to print the value of 5 or the hello world. Okay, so this is what variables are. They are simply containers that hold the value inside the memory. Okay, so they basically provide you a bridge between your code and the memory where the actual data is stored. So when we store the 5, it's actually stored inside a memory location. Make sense? Okay, so Python has no command for declaring variables. There's no separate command. You just use the variable name and then you specify it. That should do the trick. Similarly, you will learn more about Pythons in the next chapter. Let's move forward. Now we have something called comments. Well, Python has commenting capability for the purpose in code documentation. Comments are basically a simple code of line that you want to ignore by the interpreter. You don't want to execute. You just want them to be in your coding. Okay, so for example, here we have a line, this is a comment, but there's no output here, no error here. There's no output here because this is a comment starting with a hash. Anything you write with hash is completely ignored by the browser. Okay, this will be ignored by the browser. All these lines have become comment. When you execute them, your interpreter will completely ignore it. Sorry, not the browser. We are using browser here, but the interpreter, the Python interpreter, will completely ignore it. Comments are very useful. We're going to talk a little bit more about them in next session, but they are very useful in programming, and we tend to use it a lot. So comments can be used in Python code to explain the Python code. Comments can be used to make code more readable. Comments can be used to prevent execution when you are testing certain code. To use comment, we use the hash sign. Okay, so anything with the hash basically becomes my comment. We use comment for information purpose, that hey, what this line of code is doing, what this purpose of this code is. You can write the comment in front of your text as well. Remember, what this basically means is that anything after hash will be ignored. So the first line, print hello world, is executed, but the interpreter, when it reaches to this point, understands, hey, this is a comment, and then an interpreter completely ignores it. So you can write comment before it. Okay, you can write comment in front of it, you can write comment after it as well. As long as it's hash, everything is ignored by the browser. You run the code, no problem. It will just use the print statement to print the system output, and output is there. Everything else inside the comments are completely ignored. Make sense? Wonderful. So similarly, we use comments to sometimes test the code as well. So some things we want to comment out, you can even use it in front of comments. So you come here and you said, I don't want to use this, and I can use a hash here, and then maybe I use another print statement here, and I can say, for example, please subscribe if you still haven't done that, and then you can execute the code. So what this basically means, that we can even comment out the code, and then again there's a hash. This is also completely ignored, and only the line please subscribe, if you still haven't, please do that. Subscribe line is printed on the output. Okay, so comments are quite useful way of ensuring that you debug the code and hide the code, or put the comments in, leave some information within your code, what's happening inside your code. Okay, multi-line comments. Now, what do we mean by multi-line? Multi-line comments means in normal programming languages like Java, C++, C Sharp, they all have multi-line comments. In Python, technically, there is no direct way of using multi-line comment. There's only a single line comment. So if you have multiple lines, we use hash, hash, hash in front of every single line. Okay, so this is what basically there is. So in technically, officially, there's only one way of doing it, is hash. But there's another workaround to it. Another workaround is using a triple quotation marks. Since Python ignores string literals, we're going to talk more about string literals later on, but basically what means that now Python ignores this string because it has not been assigned to a variable. So it's not been assigned to any variable. That's why Python thinks, hey, this is a string, but it's not assigned to any container. So I don't know what to do with this thing. That's why Python will completely ignore this way, making this as a multi-line comment. Hence, you don't have to use hash in front of any. You can just use triple comment and triple comment quotation marks, triple quotation marks to create a multi-line comment. Okay, make sense? Wonderful. Let's talk more about variables. What again exactly are variables? So variables are basically containers for storing your data. Okay, in Python we use variables for data storage. By that we mean that whenever you create a variable, or whenever you have a data, such as in this case 5, okay, what we're trying to do now is that we say, hey, I have a this variable or this data, and I want to use this data in my coding. So I need to save this data in a variable. That way I can use this variable again and again and do mathematical operations and data processing and other operations on this variable. What happens at the back end is that for this data 5, a memory is allocated, and inside this memory a 5 value is stored, and this x actually refers to this memory location. So by accessing the x, we are actually accessing the memory location where this data is stored. So x behaves like a container. It also behaves like a memory pointer that points to the memory address where this value is actually stored. And that way you can call this value again and again by simply calling this x variable. Okay, make sense? Wonderful. So you can again, so you can very easily declare any type of variables here. To declare variable, you don't need to do anything. You just need to use variable name, x, y, z, hello, age, whatever you want to do. So you can have x, you can have x again. Now what this basically means that variables do not need to be declared with a particular type. By type means we don't need to specify what type of data it is. This is automatically handled by the Python. So if I come into this code here, this is 4. 4 is an integer number. Then again I have x, and then I change this to Sally, it becomes string. So now you see this, when I print it, it prints Sally. This means that I'm printing a string variable. Okay, it's completely ignored because this 4 value has now been overridden. In other words, assume that there is a memory location. There's a memory location here. Initially it contained 4 value, okay, but this 4 value has now been overridden by this Sally when we override it. So the same memory location now is basically overridden, and now this same memory location contains the word Sally for us. Okay, so now when you access this variable, Sally. So when you access the variable, this x variable value is basically printed for us, and then x variable value is Sally. Okay, so this means because we are not explicitly declaring a variable, not defining a type, you can override a variable to a different type as well. Okay, it doesn't only have to be same integer. In Java, if you declare a variable as integer, then it only can be integer. You cannot assign string to it. It will give an error. Then you actually have to cast it into integer, but that doesn't work in Python. It's automatically handled. That's what makes Python much more easy. But then there is something called casting. Casting means you explicitly specify what type of data you are using. In this case, we are telling it, hey, I'm using string. So this is a function in Python. If you have used functions before in any other languages, you would understand the syntax. But if you are using it for first time, well, string functions are basically a block of code that perform a specific task. We will talk about more about these functions later on in this section. Okay, in function section, we'll see how we create our own functions. But there are many built-in functions that we use regularly with Python. So what we're doing now here is we are telling our Python that I have a variable 3, or I have a data 3, but I want to be of type string. But I have a data 3. This time I want it to be of type integer, means a number form. Then I have a data 3, but I want to explicitly ensure that it is of type float, which is a decimal value. Okay, so by specifying these function names, we are explicitly defining what type of data we want to use. Make sense? So this is called casting. More about casting in the next section when we reach to the casting, how we do it. You can still find out what type of data you are using by using another function called type. Okay, so for example, you have x is equals to 5, y is equals to John. You can use the function called type and provided a value x. What this does now is it's going to print and find out what type of data this is. This is an integer. So for example, if you come here, it's going to print, hey, this is a class integer. You can use, for example, this to be x 5.5. Okay, and then when you run the code, now because you have used point value instead of integer, this becomes, yes, float. So now this is a float. Similarly, y is equal to John. This becomes my string character. Okay, so type method allows us to identify what type of method data we are using. Now remember, see this, the way we have used it. Again, if you're familiar with the syntax, excellent, but not, let me explain this in a moment. What we're doing now is we are using a print method. Inside the print method, we actually require a value. So by default, we said, hey, anything you need to print on the console, you use the print method. Typically, we use a string notation here. Okay, so this is text. So when I execute the code, print will actually print on my output whatever we have written inside inverted quotation marks. So it needs some data to be printed on our console. That's what this print function does. Again, a function means a block of code that performs a task. So this is a built-in function. The task of this function is to print the output on the console or on this output area. But because we are using type function, so what we're doing now is we are saying, hey, print the output. Okay, print the output. But what is the output? I'm going to say type of x. So instead of writing the string, I'm writing another function here. What this function will do, it will find the type of this function variable and return this value as a string, and which will be us given to print. So it's like asking somebody to pick something up and hand over to somebody else, right? So type, we have asked it, hey, find out the type, and whatever the answer is, hand over that answer to the print function so that I can print the output on the console. So we have used a function inside a function to print the output. That's what it is trying to do. Next thing, single quotation or double quotations. In Python, we have both, and both are legally allowed. As a string, you can use the double quotations, or as a string, you can use a single quotations. Both works fine. There's no problem with that. Both present the same output. Typically, in my preference, I always prefer double quotations for the string. Single quotations I represent as a character. Make sense? Wonderful. Python is a case sensitive, so be very, very careful about that. The variable names are case sensitive inside Python, means that capital A and small a are two different variables. So when you execute the code, you will notice that 4 and Sally, they are two different variables. Means that A is 4 and A capital is Sally. These two are two different variables. You can even have it in this way. So for example, I can have name is equals to, I can say my name, string, and I can have a capital name and I can say is equals to, for example, learn with W3Schools, my channel name. And then when I print these both variables together, so I can say print name, this will do what? It will go and print this name, because this is a different variable according to Python. This is a completely different variable according to Python. Why? Because this starts with capital N. Because this is a case sensitive, Python is case sensitive, these two becomes two different entities. So this is a different variable, this is a different variable. So when you print name, if I run the code, it's going to go and print the name, my name, right? Zeeshan. But if I change this from small to capital, now this is actually referring to this capital name. And when I run the code, this is going to go and print the capital letter. The output will be learned with W3Schools, the different variable. So be very specific and very clear about this, that Python is case sensitive and it will change the values with that. Okay, so this is about variables. Similarly, we go into data types and try to understand what exactly we mean by data types. So what do we mean by data types? Data types basically mean that what type of data you are using in your system. Absolutely important thing whenever we are doing programming. Okay, so whenever we are using string, it's an str type, means it's a string data. If you are using numerical values, it's of type integer or float or a complex number. If you're using sequence type, it's either a list, a tuple, or a range, means multiple data in a single variable, a sequence of different data. Okay. Mapping type, for example, is a dictionary data type that uses a key and value pair. There's a set types using set and frozen set type of data. Boolean type in terms of true and false, having a Boolean value. Binary types including bytes, byte arrays, and memory view. And none type means this data does not have any type assigned to it yet. Okay, so the beauty here is that these data is actually handled internally by Python automatically. You don't need to specify them explicitly unless you are doing something called casting. So when you're doing casting, then you would explicitly define what type of data you're using. But since we are not doing casting, these data types are automatically assigned implicitly by Python. Explicitly means, so for example, if you come here and you write this code, see this, you don't need this. So this data type has implicit type integer. Okay, it's been implicitly assigned integer data type, means automatically assigned by data type. But when you write, for example, x is equals to int 56, now what we're doing is we are explicitly defining explicit type integer. Okay, so now this is explicitly defining that, hey, I have a data and I want it to be of type integer. If you're coming from C++, Java, or C#, in Java we use integer and then variable name, for example, var is equals to 56. This is called explicit data type declaration, where we explicitly declare that this variable is of type integer containing a value 45. Okay, this is explicit declaration. This is explicit declaration in Python, but Python accepts implicit declaration as well, means you don't need to define the type. This is automatically handled by our Python interpreter. That's the beauty here. So it removes lots of complications and fuss about understanding what's happening. And then we can use the type function to determine what type of data it is. Again, we have talked about type already. Setting the data type. So for example, when you use x is equals to hello world, because you're using text, it is of type string. But you actually just use x is equals to hello world. You are only concerned with this. You don't worry about other than that. But you have to know what type of data you are using, because based on that actually memory is allocated. So the Python needs to know what type of data it is, but it handles implicitly. So it's not technically your tension or not your responsibility to worry about it, because it's being handled automatically by Python. But knowing that these data type exists is important, because you're going to do various different operations based on what type of data you are using. So to know what type of data it is, it's quite important. That's why we have a type function to determine what type of data we are using. So if it's string, it's hello world, it's a string data type. If you use a number, it's an integer data type. If you use decimal values, it's float value. If you use complex numbers like 1j, it becomes a complex number. The j here is an indication that it's of a complex data type, not of integer. Integer only uses 20, but if you use the j keyword, so there is specific keyword specified in terms of complex numbers. And similarly, we have lists, we have tuples, we have range, dictionaries, sets, frozen. So these are all different types of data that we use. More about list, tuple, range in these sections here we're going to talk about later on, but this is like a collection of data where with each single variable has multiple data. Now previously in normal case, single variable has a single value, single variable has a single value, single variable has a single value. Here single variable has multiple values. This is called a list, beginning with square brackets. Then if you use round brackets with multiple values, comma separated, this can be of string, integer, or you can mix and match. This is called a tuple if it has round brackets. Then range basically means I'm specifying a range of values from 0 to whatever number you specify here. So it will automatically have 1, 2, 3, 4, 5 up till that. Okay. Similarly, we have a dictionary that contains key and value pairs. So name is key, colon, its value is John. Age is key, colon, its value is an integer number. Again, we talk more about this in dictionaries later on. So these are different types of data that we can use inside Python. Let's talk a little bit about numbers. There are three types of numbers that we can use in Python. We have integer, we have float, we have a complex number. Variables of numeric types are created when we assign a value to them. So for example, when you assign 1, this is considered as an integer data type. When you assign a value 2.8, this is considered as a float. When you assign 1j, it automatically becomes a complex number. Okay, if you execute, you see that the Python will now know, oh, it's an integer, oh, it's a float, oh, it's a complex number. Okay, using the type function, we determine what type of data we are using. So integer or IINT is a whole number, positive or negative, without the decimal or unlimited. So whether it's a 1, whether it's a very large number, whether it's a negative number, they are all considered as an integer numbers. Float, anything with decimal values with 1.1, 1.0, 0.1, 35.59, all these are float, means decimal number values. Okay, similarly, you can use complex numbers as well. For example, 3.5j, this is complex number, 5 is a complex number. So complex number are written with the j as an imaginary part. So this becomes as a imaginary constant path, indicating this is a complex number. Then we have something called type conversion. Okay, type conversion means to convert from one type to another. Okay, this is called type conversion. Means you start a number with an integer, but then you want to change it to a float, or you start with a float and you want to change it to an integer. Okay, to do that, this is how we basically proceed with the code. So convert from one type to another. Okay, that's why I said some data types are implicitly handled, but knowing which type of data you're using is quite important, because you might perform certain operations on them, like typecasting. Okay, so this type conversion means we are changing the data. Here, what we are doing is that I'm saying, hey, variable A, again I declare a variable, is equals to float x. So x initially is of type integer, but here I'm specifying that I want to convert this integer into float. Okay, so this is casting, type conversion, converting x into an float value. So now a will be 1.0 decimal value. Similarly, convert from float to integer. Now I can say, hey, I have a y 2.8, this is a float value, but I want to convert this y into an integer. So using a function, I pass it an argument as y, which is the value 2.8, and I'm saying, hey, convert this 2.8 into an integer and assign it to variable b. So this equals to is an assignment operator actually. This means that assign the value of this back to the variable b. So we take the value of y, which is 2.8. We say, hey, take the value 2.8, convert it into an integer number, and then after conversion it, assign it back to the variable value b. So when I print it, it will print the value of b for me. So if you execute the code to see how the outputs are rendering out, we will see that we have float 1, which is again decimal value. We have float 2.8, because we converted into an integer number, the decimal point value is lost and only the numerator, or what they call it, the value before the decimal remains. So 2 becomes integer and 0.8 value is now lost or ignored. And then when you convert 1 into a complex number, it becomes 1 plus 0j as a complex form notation. You can check out its type, and now it becomes float, integer, and a complex number. Okay, this is how we handle numbers and values. If you go into casting a little bit more, it talks exactly the same thing. Casting means type conversion, or type conversion means casting. When we cast using these functions one data explicitly into another data type. So I have a 1 and I explicitly say, hey, cast it into an integer. I have value 2.8 and I say, hey, explicitly cast it into an integer. I have a value string 3 and I can say explicitly cast it into an integer. So if you execute the code, all these value 1, 2.8 and 3, all they become an integer number. If you check their types, they again will be of type integer. So casting or type conversion is basically same thing. It means that we are converting one value from one data type into another. And there are built-in functions to do that. Integer will convert it into integer, float will convert it into a float, and then so on and so forth. Okay. Then we have something called string. So strings, well, strings in Python are surrounded by either single quotations or double quotations. Obviously, they are text, so you have to use either single quotations or double quotations in order to Python to know that they are basically strings. You can display string literals using the print function, and you can print them. So whenever you use double quotation marks or a single quotation marks and have a bunch of characters inside them, they basically represent your string. So every string gets printed as it is if you use it inside the print method. Do remember that Python supports both double quotes as well as single quotes. I personally do prefer double quotation marks throughout, and I tend to use double quotations for my strings. Just keep it consistent. So if you use double quotes, don't mix and match, just confuses the developers down the line. Anyway, quotes inside quotes, yes, if you have to use quotations inside quotations, just like in this case. So for example, he is called Johnny, and you want Johnny to appear inside quotation marks. So what you do is you use double quotations outside, and you can use single quotations inside. That way, when you print it, it will print single quotations as it is. Python recognizes this, understands this, that hey, this is a single quotation inside the double quotations, so this single quotations gets printed. And vice versa, if you want to print double quotations, print double quotations. So what you need to do is you need to use single quotations outside and use the double quotations inside. Again, it understands what you're trying to do, and the outside single quotes becomes a string, and whatever comes inside this string gets printed as it is. Okay, assign string to variable. Well, we have already talked about this in previous topics. Simply put, any string can be assigned to a variable. Usually it's preferred, again, a good variable tip is you use a proper variable name. For example, a name makes much more sense than just the a variable. If you're using name, first name, father name, variable names should always be a proper name. Make sure you just don't use spaces between the variable names, or don't start with a number. So once you do that, you hit the run code. Now you can print the variable whatever it is, and it gets printed on your output. Okay, so you can assign a string to any variable for that matter. Multi-line strings. Multi-line string means that if you have to use multiple lines of strings, then you need to use triple quotation marks. This is something that is there. So if you use double quotation marks, it would assume, for example, if you use two double quotation marks, it would assume that you're trying to use just quotations inside the quotations, and it won't understand what you're trying to do unless it's like a single quotation marks, and then it understands, okay, so we have a string literal and this is the single quotation marks. But if it is supposed to be multi-line, then you must use triple quotations, because now you can see that it's already confusing what's happening here. So even if you use single quotations, double quotations, and then single quote to get it printed, if you run the code, Python gets confused at what's happening with these three lines here, and it generates an error. So if you use double quotes again, it assumes that you are using quotations inside quotations. It again will generate an error and will get confused what exactly is happening here. Okay, so that's why if you are using multi-line string that you have supposed to process, maybe you're doing some text processing, analyzing on some text to speech, NLP codes, basically your multi-line string has to be inside triple quotations. Only then it will understand, okay, you're using multiple lines of comment. You can assign this multiple lines of string into any variable and print that variable, and then it will run perfectly fine. Okay, yes, if you don't assign it to a variable, we have already talked about this. Now Python consider this as a string, yes, but it hasn't been assigned to any variable. Okay, and because it has not been assigned to any variable, this a gets error because nothing has been assigned to it. So for example, if I say some text here and then print it, what will happen is that this will become a comment. Python will consider this as a comment and it will say, hey, what's happening here? I don't understand what you're trying to do. So it will generate, in this case, generate an error because this is a multi-line with a space here. Okay, so note there's a space here due to that indentation thing. It generates an error and blurts out so many things. You can find out this at this line here, an indentation error, unexpected indent. So even this indent here, even there's no parent here, but because there is a space, Python assumes that you are trying to indent it, create a block of code, and there's nothing above it, it get confused. So indentation is very confusing in Python sometimes. So just make sure if there's error of indentation, make sure there's no indentation here and unwanted. So if I remove the indentation, recompile and re-execute the code, now you would see that we get some text and all these lines are basically considered as comments. Okay, so multi-line string are there. You need to use it with triple quotations, making sure you assign it to a variable to be able to use it. If you don't assign it to variable, it will be considered as a multi-line comment inside it. Okay, similarly, three single quotation marks. Okay, so you can always vice versa, just like triple quotation, the triple double quotes, you can use a triple single quotes as well. This would also work perfectly fine as well. Now, one thing to have to understand that in Python and similarly mostly other languages as well, internally strings are considered as an arrays. What do we mean by that? We mean by that that when we create an array or when we create a string, sorry, every character in a string is assigned a specific index number, and internally it's like having multiple characters assigned to a single variable which is defined in terms of an array. Okay, which is like an array, meaning that an array can have multiple characters within a single value with a single variable. The only difference with the string and pure array is that array you need to use each character with a comma separated value. Okay, but with a string you don't need to use comma separated values, you just use a normal string and it is considered that. But because internally it is behaved as a string, hence you can access individual characters in a string as well. Every array element starts at the 0 index, then at the 1 index, then at the 2 index, then at the 3 index. So by default, every character has assigned an index number, which is like page number. So every character has a specific number, that what is the location of that character in this string array. So it identifies the location. So 0 is starting point. Always every string starts with 0. So the H is actually on 0. E is actually on 1. So that's why when we say go to this variable, square brackets indicate that I'm accessing an index element. Okay, so square brackets say, hey, access a specific index number 1. So whatever character is on this 1 index will be printed on our console. So for example, if you want to print 0, so you just type in 0. If you run the code, this means print the character on a 0 index, which is H. So it will print H here. Make sense? Perfect. Now looping through a string, because this is considered as an array, we can loop through each character array as well. Okay, just like we would do any other things. We will talk about for x and for in a little bit later on in this chapter here. But what this basically means is that for is a loop. It has a syntax that it will automatically repeat itself. Okay, this line of code will actually repeat itself until a condition is satisfied. In this case, what we're trying to do is that, hey, loop itself, reiterate the statements, execute it again and again and again. That's what for does. It executes a line of code again and again and again until it becomes false. Okay, so it says, hey, for loop again and again in banana. Okay, loop this string again and again, read one character in this banana and assign it to x. Okay, so read first character, assign it to x, and then print the value of x. Go back up again. Now read again the second character in this banana and assign it to x again, overriding the previous value, and then print it again. Then again the loop through the third element. Again read the third character, assign it back to x, overriding the previous a, and then print that x. And loop, so that way it will loop all the characters until it reaches the end of a string, end of a character. When it reaches the end of the character, now the condition becomes false. Now it says, hey, there are no more characters to loop through. So it says, okay, since there are no more characters, exit. So see how many things are happening with just one line of code. With just one line of code, we are actually traversing each individual characters in this string array. Okay, so when you print the whole string, it prints them as a whole one thing. But when you loop through each index, it prints each individual things. This is extremely useful if you're working in NLP and processing text or some text processing application where you want to process individual characters and find out various different things from a given string. So we need to use this looping statement. So for in loop is used to traverse through string characters. So individual characters can be traversed. Colon here indicates that this is a continuation statement. There will be a certain statement after this colon, in this case the print statement, and because the print is a child of this main block, hence it has indentation as well. So do keep this thing in mind. If you write print at this line, it will be generating error because we supposed to have a block here. Okay, string length. Now string has various different functions that you can use. For example, there's a function called length. It will tell you how many characters in this string are. So no matter whatever string you have, it will tell us that there are 13 characters. 1 2 3 4 5 6, comma is a character, even a space is a character inside the string, exclamation mark, whatever you write, every single thing will be counted and it will give us a total number of length. Okay, so now we can say, hey, we have a string length. So length function is commonly used to determine how many characters are there in a particular string. Similarly, you can perform the check function. What this does is it does similar to searching. Okay, so it has a built-in search if you use the word in. Okay, using this keyword in, we can easily find a certain given text from any given within a string. Okay, so what's happening now is that we write a text. This says this is the best thing in life, or free, wonderful, and then we say, hey print, find me the free in text. Okay, so what this will do is it will return either true or false, whether this string free, this word free exists in this given string or not. So it can very easily do a search for us by simply using this in keyword. So in keyword allows us to search a given string in another larger string. Okay, so we can do searching using this in keyword as well. Similarly, you can put this in an if to do more customized and conditional search as well. For example, we can say, hey, I have a given string. If, again, is a conditional statement, it checks a specific condition. Okay, so it checks if something is true or false, if this exists or not. So it says, hey, if this word in means, again, search text. If this exists, print yes, free is present. So instead of just printing true or false here, now we can print our own custom message that if this condition actually exists, what should we do? So this becomes a conditional check. Check whether the word exists in this or not. Okay, similarly you can check not as well, not in, with this keyword not and using the in itself. So this means that we want to ensure that this word does not exist in this keyword. So more like online comments, we can check for certain words, bad words, check for specific prompts, specific keywords within a given string, or ensuring that that keyword does not exist in a string. So vice versa, not keyword is used to ensure that this word does not exist in a keyword. Similarly, you can use this in if as well to ensure that this is existing or not. To do that, we can use if expensive not in text. No, expensive keyword is not present here. Okay, so searching within a string also makes much more easier with this in keyword, or you can do the inverse search ensuring the word does not exist using the not. So this is a little bit about strings, how we use them. Then we talk more about booleans. Booleans are basically true and false values. Just like in strings, you saw that we got an output in form of either true, and if it does not exist, it will give us false. This value has to be saved in memory. So in memory, this type of data needs to be stored. So what type of data is true or false? In computing, in programming, we call them Boolean values. Either Java, C++, Sharp, C Sharp, whatever you go to, you would use these Boolean variables. Boolean only contain two types, either true or false. Usually true is 1 and false is 0. That's why we call them binary operators as well, or binary conditional statements as well, which means that it only checks either it's 0 or 1, true or false. If it is true, the value is 1. If it is false, it's basically 0. So these are called Boolean data types. Okay, Boolean meaning true and false. These data types ensure that when we receive a value, the system knows that this is the type of data. Remember, we talked about variables and data types. Whenever we create a data for a programming, the data has to be stored in a memory, whether it's a runtime or a permanent in a variable. When we store that data in a memory, memory needs to know what type of data it is. Based on that, it will allocate the space and store that value. Okay, so that's why data types are important, whether it's an integer, backup, float, or string, or even a boolean. So when we receive an output true and false, this true is actually saved in my memory right now, and from my memory the browser is reading the data. Okay, so This true, when it's saved in a memory, it needs to know whether it's of type true, of boolean, integer, character, short, or so on. So that's why we have a boolean data type as well. It only contains either true and false. How do we obtain this value? Well, there's something called operators. We'll talk about this in the next session or in a moment. But we use certain operators to determine certain conditions, and the output of these operators is always a boolean value. Okay, we use these operators to evaluate an expression, and the answer of this expression is always in form of true and false. So when I have 10 greater than 9, this is a greater than symbol. This greater than symbol means that we are evaluating an expression whether the value of 10 is greater than 9. If this condition is true, it will return true for me, otherwise false. Similarly, 10 double equals to 9. Now notice we have two equal signs. This means we want to compare that the value of left hand side is exactly equal to value on the right hand side. So 10 is equal to value of 9. Hence this becomes false. Obviously they are not equal to each other. 10 less than sign. So this is a less than symbol. So this basically means 10 is less than 9. Again, this condition becomes false. So once you execute the code, now you start to get an output. The first, yes, 10 is greater than 9. Boolean value is returned, which is true. 10 is not equal to 9. Hence, we get a false value. Okay, again a boolean value, so the system understands this is a boolean value, and similarly 10 is less than 9. Again we get a false boolean value. So boolean are basically always returning true and false for us. These boolean values primarily we use with the if statements. Okay, again we're going to talk if statement a little bit later on. If statements basically allow us to evaluate a condition based on an expression. So this is actually an expression. This expression returns either true and false. If it is true, the if gets executed. If it's false, the else statement gets executed. Okay, so it's a conditional check that we do. This is where the true logic comes into play. We get a variable, we get some data, and we want to evaluate that data. So that evaluation is done through various different expressions. That expression have to return true or false value, because if technically only needs true or false. If it's true, the body of if gets executed. If this expression is false, this line gets completely ignored and else is executed. So if you execute the code, you will see the answer is B is not greater than A. Why is that? Because B is 33, A is 200. So when we use the expression B is greater than A, hence we are evaluating an expression that is the value of B greater than 200. So in this case, the condition is false. Okay, so because the condition is false, this line is completely ignored and this line gets executed else. Okay, do keep in mind there can be multiple lines below it. Oops, control Z, oops, control Z, sorry, and control C, and again. Okay, so we can copy this line. For example, if I have paste, 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 I can use multiple lines here. Similarly, I can say, hey, let's just copy this line and paste, paste, paste here. So if I execute the code, you will notice that B is executed, this line is executed 4 times. Why? Because we have 4 print methods. Okay, so you can have multiple lines below this else. As long as indentation is kept, this line will execute. If you remove the indentation like that, boom, error will generate. Then after this block, actually I can remove the indentation just like that. Now notice what will happen. If I execute the code, I still get 4 outputs. Why should I get the 4 outputs? Why there's no error here? Because at this point, else got executed. It executed these 2 lines as a part of else. And then these 2 lines actually are no longer part of else. So if I say outside, and then I print outside here as well. So I say, oops, outside. Okay, just to make sure things are happening. And then if I crank this value up to 333, so now B value becomes 333, since B becomes greater than A. That means actually these lines should execute. So if I run the code, boom, we get the 4 lines from this if B is bigger than A, the condition becomes true. Hence, these 4 lines gets executed. Once these 4 gets executed, after that, notice these 2 lines are also getting executed. These 2 lines are also outside. Why? Because we have removed the indentation. Now else is only concerned with these 2 parts. These 2 lines are no longer part of this if and else block because we have removed the indentation. If you do the same mistake with this thing, bang, and we assume that, hey, since we can do else here, we should be able to do this here, but now this will generate an error. See this? Why? Indentation error, unindented does not match, blah, 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 blah things. Why? Because this content is still continuing. This becomes a whole block. If you write if, block start, print statement, what should I do with this print statement? Because else is actually part of an if statement. If block. So once this block gets true, these all lines have to be inside the same block to get executed. That's why indentation matters. So these indentation, if I remove it, now should be okay. But once I do this, this can be easily considered outside of the block. So I can just write it like that. So now it says, hey, if ends here, and these two are completely outside of the if block. Okay, so do keep in mind about these indentations and the expressions. We expressing few things later on as we go. So evaluating the value, we can easily check with the Boolean function as well. We have a Boolean function that allows you to evaluate any values and give you true and false in return. So for example, we say Boolean hello and Boolean 15. So if I execute the code, what this will basically say true and true, it will evaluate and just give me that answer as it is. So for example, I can say x is equals to hello and y is equals to 15. I can use this in Boolean expression as well. Okay, so most values are true. Basically, this is how we're working. Almost any value is evaluated to true. So anything you write here will be considered as true because there's no actual comparison. We are not using any comparison operators here. That's why everything is returned in form of true here. Any string is true except empty string. So if you leave it empty, okay. So if I leave this as an empty string, now if I run the code, it says false. Why? Because there's no string here. So it has nothing to compare with. That's why it becomes false. So sometimes we can use this method to evaluate if the string is empty or not, whether the user has typed some answer or not. Is he given username or password or not? Has he left it blank or not? Any text field in the system is blank or not? You can very easily see, read the text data and see if it's Boolean empty or not. If it is empty, if return false, means a user has not entered anything, and then we can use this in expression given any message with that. Okay, any number is true if it is except 0. So if even for the number as well, if you leave this to blank, this becomes false. Okay, so this becomes true and false value in terms of Boolean things. Then let's talk more about operators now. Python operators are again various different operators that we use. We have seen the plus minus or in general programming, in general arithmetics, but there are various different other operators as well. Most commonly, arithmetic operators are there. We have assignment operators, we have comparison operators, we have something called logical operators, we have something called identity operators, we have something called membership operators and bitwise operators. There are various different operators available. Okay, the most common we have arithmetic operators. Again, they are almost self-explanatory. Whether you want to do addition, we use the plus operator, x plus y does the addition, subtraction, minus, multiplication, division, modulus gives us the remainder, exponential means exponent 2 to power 3, so x power to y will be there, and the floor division method will be there, and the floor value will be returned after the division. Okay, so these are standard arithmetic operators. After that, we have something called assignment operators. Now they are quite interesting. Assignment single equal to, again, we have already used this, x equals to 5 means assign the value of f5 to this x. Okay. Then we have something called plus equal to. This is called a shorthand operator as well. This means we write x plus is equals to 3. This actually evaluates into this thing. So this basically means that take the value of x, plus it with 3, and then whatever is the answer, assign it back to the same x. Similarly, minus equal to means take the value of current value of x, minus it with 3, whatever is the answer of this, assign it back to the x. So x minus equals to 3 means that. Okay, so it's called a shorthand operator. Usually I write it in this way, makes my life much easier, but there are people preferring shorthand operators as well. So we have plus, minus, multiply, divide, modulus, and so on and so forth. Make sense? Perfect. Then we have comparison operators. Okay, comparison operators always render result in form of true and false. Keep that in mind. Okay, the expression will always evaluate to an expression and give answer according to the mathematical solution. Same goes with arithmetic operators as well. But comparison operators always return either true or false. That's the two answers you will get, true or false. So double equal to means you are comparing value of x with exactly value of y. Are these two values exactly equal or not? If they are, you will get true. If they are not, you will get false. Similarly, not equal to, again, they are not equal to each other. They can be two random values. If they are not equal, the answer will be true. If they are equal, the answer will be false. Greater than, the value is bigger than x and y. Less than means the value is smaller than the value of y. Greater than, equal to. Now this is interesting. This basically means, if you try this one out, this basically means that currently it runs true because x is greater than and equal to y. But what if I make y value 5? Okay, and if I remove equal to now, if I run the code, what this will return to us, it says false. In fact, they should be okay, right? But x is greater than y means x value is bigger than y, which is not the case. They are both equal to. And in some cases, we need to make sure they are equal to. So that's why we use the symbol x is greater than equal to y. Now it becomes true because we are saying, hey, they are greater and equal to. So this basically has two comparisons in one symbol. Okay, so they are checking two things: greater than or equal to, less than or equal to. Okay, so at this point we are checking two different things. So we are also checking that they are either bigger or equal to in one single group. Make sense? Perfect. Okay, then we have something called logical operators. Well, logical operators, we have already seen the use of not. There are something called and or. What these logical operators do, quite importantly, they actually evaluate two different expressions, and based on that they give us an answer, again in form of true or false. Evaluating two different expressions, we mean that previously we just use one single expressions. These comparison operators by default only use one expression, one expression, one expression. In programming, sometimes we need to evaluate two different expressions, and based on that we want to make a decision. So to easily do that, we use and, or, and combination of not. Okay, so what this now means is that we're saying, hey, x is less than 5 and x is also less than 10. Okay, so now we are using two comparisons before we make a final decision. Similarly, x is less than 5 or is less than 4. Okay, so let's see an example of it to better understand how things are working. So x is 5, and then I can say, for example, x is greater than 3, condition is true, and x is also less than 10. So I can ask people that, hey, enter your number or enter your, for example, age. So we can say, hey, age, enter your age, and we want to make sure that this age is greater than 18 and less than, for example, 30, because I want this particular program to run for only this particular age group, somebody who's above 18, and I have to ensure they're also below 18. So if I run the code, now it actually runs false because again the age is false. Here's the key thing. Using AND operator, now I got a range between 18 and 30. So we are evaluating two expressions. We are saying, hey, evaluate whether, sorry, let me correct this to age again, whether age is greater than 18 and age is less than 30. So if I say, for example, 20, 29, or let's just go with that, this becomes true. Why becomes true? Because my age now is bigger than 18 and less than 30. What if I make it to, for example, 32? If I run the code, now this will give me false. Okay, why this will give me false? Because my age is greater than 18. Yes, so this should be true, but because we have used and, it has to also ensure that this condition also is true, so this becomes false. Instead of and, if I use or, okay, so if I use or here and execute, now it becomes true. Why it became true? Previously and was false because and was a very strict range. Or is a very flexible range. It requires either one of these conditions to be true. And has to ensure both of these conditions are true, or requires that any one of them becomes true, it becomes true. Hence, when my age is 32, age is greater than 18, this condition becomes true. Perfect. So since this becomes true, it is no longer concerned with this value, and it will ignore it, and based on this, I get a true answer. Make sense? Yes. So this is what and or does for us. Similarly, we have a not, which actually reverses the result, returns false if the result is true, and returns true if the result is false. So it actually inverses the result in certain scenarios. Then we have Python identity operators as well. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object. So when we go into OOP sessions in the next video, We will talk more about is because it actually uses object comparison, not the data value comparisons. Okay, so these are various different operators. Just go through them. Basically, what does the same tasks, similar tasks, not the same tasks. Okay, now let's move on to lists quickly. Okay, so lists are used to store multiple items in a single variable. Up till now, we have been using variables and data types that store a single value. However, in certain situations, most common situations, we need to store multiple values in a single variable. To do that, we use something called lists in Python. Okay, so lists are one of four built-in data types in Python used to store collection of data. By here, we are now using word collection of data. That means that a data type that holds multiple data together. So there are lists, then we have something called tuples, we have something called sets, and then we have called dictionaries. Okay, so these are all four main type of collection data types that exist in lists. In Python, sorry, list is one of them. So list is one of them. Then we have something called tuples, then we have called sets and dictionaries. All of them four basically work on the same principle, that they hold multiple data in a single variable, with a slight difference, of course. So what exactly is a list? As compared to the list is basically are created using a square brackets. Okay, so each list items are ordered, changeable, and allow duplicate values. So when you have a list, you can have multiple values to give within list using a square brackets and comma separated. Simple as that. You can have integer, byte, float, short, all any type of data is acceptable. The only key difference is the lists are ordered, they are changeable, means you can change the list and you can allow duplicate values to exist within a list. As compared to that, we have something called tuples. Now, tuples again are same collection of data type. However, for tuples, we use the round brackets. Okay, for lists, we had square brackets, but tuples use round brackets. Tuple again is part of those collection of data, right? They again hold multiple data, comma separated. The principle is same. You can print the whole list using the same list variable. The only difference is within the tuples and the list starts with the square brackets, tuple starts with the round brackets. Then the major difference is tuple items are also ordered, but they are unchangeable and they do allow duplicate values. But unordered means that when we use the list, the tuples are ordered. It means that each item have a defined order. So when we have apple, apple is at a 0 index, this is at a 1 index, this is a 2 index. Same goes with the lists as well. Okay, so I'm just mixing both together so we can cover much easier. So when you create the list or tuples, the major thing is both are ordered, both have 0, 1, 2, 3 index numbers. However, the difference between list and tuple is list is changeable, tuple is unchangeable. Items index, tuples items are indexed. The first item has a 0 index, the second item is blah 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 things. So when we talk about order, we say that when we use the tuples or ordered, it means that the items have a defined order, starting with the 0 index and going to the 1 index. Every item is placed on a specific index number. However, when we say tuples are unchangeable, means that we cannot change, add, or remove item after the tuple has been created. However, when you go to the lists, list items are said to be ordered. Yes, they again also have 0, 1, 2, 3 index. However, the list items are changeable, meaning that we can change, add, and remove items in the list. Okay, so we can do that within the list. Then list is allowing duplicates, so does tuple. They both have the same feature, means I can have 2 bananas inside it, no problem. I can have 2 cherries inside them, no problem. However, this becomes a different case when we go to the sets. Okay, so when we talk about sets, now sets is again same collection of data used with curly brackets. So let's square brackets, tuples, round brackets, sets, curly brackets. But the difference now is that set again is unordered. Remember, list and tuple are ordered. They are unordered. Means that when we have apple, banana, cherry, every time you exist, the sequence will change or it can change. There's no particular order which item is first, which item is second, which item is third. Second, it is unchangeable, means once you create, now you cannot change it. You have to create a new list. It is unindexed. Okay, there's no 0, 1, 2, 3 index number. That's the major thing. So all items are unordered, unchangeable, and do not allow duplicate values. So if there are duplicate, they will automatically be removed. Unordered items means that items do not have a defined order. Unchangeable again means that you cannot change the items after it has been created. Not allowing duplicate means that even though there are 2 apples, when you print the list, it will just print a single apple and it will not be allowing any duplicate. There won't be any error though. No to worry about that. Say this, there are 2 apples, but it prints only one single apple. Why? Because these duplicates are not allowed. So even though there's a duplicate item in the list, it doesn't generate error. In the output, it just removes them. This is what we mean by duplicates. Finally, we have something called dictionary. Dictionary is quite different from all above three. So dictionary is something different from lists, tuples, and sets. The way dictionary work is that it uses a key and a value pair. We create a dictionary with the curly brackets, but instead of directly giving a value, now we have something called a brand, which becomes a key, colon, its value. Again, comma separated, a model, which is a key, colon, its value. So every item, instead of being mapped to an index number, is now mapped to a key value, and then it has a value information. So we have a key instead of an index number, we have an actually a text. All right. So instead of using 0, 1, 2, 3 as an index, we are actually using the name of our own choice to identify value that goes here. So imagine this is 0 index, but 0 is boring, so we use it as a brand. Now I can easily call brand. So dictionaries are used to store multiple values in a specific key value pair. That's the key idea of dictionary. Okay. In other languages, we call them hash structures as well, a hash table form. But in Python, we call them dictionaries. So a dictionary is a collection of ordered, changeable, but they do not allow duplicate values. So you will have an ordered list, because again, each item is mapped to a specific custom index value. So it has a specific sequence, we can say, but they do not, they are changeable, you can change them, but they do not allow duplicates. So you cannot have a two duplicate keys inside it, right? So there can be different values or duplicate values, but the keys have to be unique. Okay. The way we use this is, if you come here, now we just say, hey, I want to print this dictionary and then the key information. So we say this dictionary dot square brackets and key. So instead of using index number, we use the key information. Okay, that makes much more sense. Easy to use. This is again similar to the JSON form notation as well. So once you understand this, now let's talk more about if else. Well, if-else are one of the most fundamentally important concepts in programming languages. If-else allows us to build that logic that we need in our programming language. Basically, if-else are conditional statements that take conditions or evaluate an expression based on a certain condition. They usually, we use these conditional operators that we have discussed in previous session in Python operators. Equal to, not equal to, any of them can be used. The idea here is very simple. So if you come here, uh, if statement is written by using an if keyword. The if keyword evaluates an expression that's written in front of it. If the expression is true, the statement below the if will be executed. Okay. If the expression is false, the statement below it will be ignored completely. Okay. Make sense? Yeah. So it's a that's why we call them conditional statements. What they do is they check a condition. So in this case, we have a B greater than A. So if is actually checking a condition, or what we say, this is an expression. This expression is a conditional expression. When this is evaluated, it will return either true or false, because we have talked about these greater than, less than symbols. So if the expression returns true, the if block will execute. If the expression returns false, the statements are completely ignored. Okay, this does not get executed. So based on the condition, it makes a decision whether to execute this line or not. That's why they call it conditional statement. So based on certain condition, they evaluate whether I need to execute this guy or not. Do remember indentation. If condition and a colon. Colon indicates that this is a still continuation. There is a still lines of code after this, and those lines of code has to be indented. If you don't use indentation, error. There can be multiple lines here or a single line here. Depends on how you want to write the conditions. Indentation is absolutely important in if-else statements. That's what this W3Schools also emphasize on indentation. Okay, so do please ensure that you always write a proper statements. Then we have something called elif. Elif keyword is Python's way of saying, if the previous conditions were not true, then try this condition. So it's like a nested conditions, a condition after us another condition. So it says that, hey, if the first condition became false, only if the first condition becomes false, now try to see if this condition works. If this becomes true, then that's it. Then this whole block will be ignored and it will not be executed. If this condition is true, the elif statements will not execute because this is already true. However, in case when this condition becomes false, then elif will re-evaluate another condition and say, huh, if that doesn't work, let me try this one. So that's where the conditional loop or conditional logic comes into play. So elif stands for else if. It means that we have an if inside another else if. If this condition becomes true, perfect, execute this and ignore all these lines. So these will be ignored automatically by the interpreter. However, if this statement is false, only then this condition statement will again re-evaluate a different condition. And if it is true, again this statement will execute. Okay. So if I execute the code, you will see A and B are equal, means the second line is work. For example, if I use this as 334, if I run the condition, now A is 33, B is 334. I have increased the value. So B is greater than A. This condition becomes true. In that case, the first one is executing. However, if you change the condition, for example, if I make it just 3, now B is greater than A, this condition becomes false. Else, if A is equal to B, so if this is A is not, B is not equal to A, if B is not greater than A, then check whether A is equal to B. So we are checking two conditions. If both of them are false, what happens now? See, there is no output. Why? Because actually both of these conditions becomes false. So we say B is greater than A, B is 3, A is 33, sorry, it doesn't work. How about elif? If this doesn't work, can you check whether they are equal? If even this doesn't work, then what should we do? Right? So since there is no more statements here, there's no output here as well. Okay, so do keep thing in mind. That's why then we come into something called else. In that scenario, now we use else statement. Else means if both if and elif become false, both of these are false. And in that scenario, we execute elif. Else, we execute else. So as a last resort, if nothing works, then you go and execute the else statement. So we say 200, 333. So B is greater than A. No, this condition is B is 33, A is 200. This becomes false. Then we say, else, check this condition. If A is equal to B, again, these two values are different. This also becomes false. So since both of these statements are now false, what should I do? But I still want an output. In this example, there was no output, right? So this doesn't make sense. So that's why we need to use another statement called else. Else colon, again indentated print statement. So this will only execute when both of these conditions are false. Okay, so we have what we call an else, if else condition statements that evaluate an expression based on these conditional operations. So we use these conditional operators. Why we always use them? Because all of these conditional operators return either true or false. Okay, and if statement in fact only needs either true or false, and the only way to get a true and false is we either write true and false, which will mean the statement is always true or always false. So it doesn't really make sense. So the only proper way of getting is then we use these conditional statements. Okay, so equal to means both variables are equal to, not equal to, less than equal to, greater than equal to, so on so forth. So that's why you see that if statement always has these conditional statements. Then finally, let's talk more about loops. Looping statements in Python are again very important after if else. So if else have conditional statements. They evaluate a single condition. If the condition is true, statement executes. But loop will keep on repeating the statement until the condition becomes false. Okay, so if else only execute one time, condition is true, executes, ends it. Loops also evaluate a condition. However, they continuously re-execute the same statement again and again and again until that condition becomes false. Okay, so there are situations where we need to repeat few things multiple number of times until a certain condition becomes true or false. And in Python, to do that, we have either while loop or for loop. Two most commonly used loops we have. So the way we use while loop is we say I is equals to 1 while I is less than 6. So this is called initialization part. This is where again you see we use a condition. And then we have a colon, means there's a statement continued after it. So we give an indentation. We say print the value of I. And now we see we have a looping statements 1, 2, 3, 4, 5. So until the value of I is equals to 6, this statement will continue to execute. Now, here's an important thing to understand. Every loop has a cycle, and you need to understand how the cycle works. Initialization only is done one time. Obviously, that's why it's written before the loop. It checks I is less than 6. Is the value of I less than 6? Yeah, condition is true because I is 1. It's less than 6. So it prints Y here. Print I, print 1 here. Make sense? Perfect. Then we say, now come here and add 1 to the value of I. Now we want to increase this value of I because we want to ensure that at a certain point this condition has to be false. Loop has to false. If you don't do that, this loop will run forever and ever and ever, and it will become an infinite loop forever. So that's why we now have an incremental statement. Now we're saying that add 1 to I, okay, and then this loop will again recontinue itself. So while automatically hazard that it will continue. So now I becomes, after adding 2 is less than 6, condition true, prints 2 here. Then I is 3, prints I3 here, and so on and so forth. So looping statements will repeat itself. It has 3 main basic structure. We initialize a variable or a value, we check a condition, and then we make sure we have an increment. Okay, that way we ensure that at a certain point a condition is satisfied, otherwise the loop will always go. So that's why the W3 schools also says, remember to increment I or else the loop will continue forever. The while loop requires a relevant variable to be ready, so that's why we always have an I as a ready variable, and we use this or initialize it before we use the statement. There is a break statement as well that you can use that allows us to stop the loop if a certain condition is met. In this case, I want to say start with 1. If I is less than 6, print the value of I. However, if the condition reaches 3, break. What this means is skip. Okay. Hence, if you run the code, you see we have 1, 2, 3. So when a certain condition is met, we can break our loop and stop its execution. Hence, the execution flow is stopped and loop doesn't continue after 3. Okay, so break statement is used to do that. Similarly, the same thing goes in the for loop as well. A for loop also does exactly the same thing, but for loop has a much stronger syntax and much broader use in Python. So for loop is used for iterating over sequence such as lists, tuples, dictionaries, sets, or a string. Okay, so when we talk about for loop, it's not only just repeating certain variables and values, but for loop has a deeper use inside it. You can use for loop to iterate through lists. So we talked about this already. The tuples, sets, dictionary items, and so on and so forth. This is less likely for keyword in other programming languages. This is a very not so commonly used in other languages. Basically, that is it means. Okay, so with for loop, we can execute a set of statements once for each item in the list of tuple sets. What do we mean by this? Let me explain. So when you come here and you see this statement here, let me execute the code. Voila. You see it prints banana, apple, cherry. With only this one line of code, it iterates through all the items and prints it. So we have a list because we are using square brackets. We say for x in fruits. Now what's happening here is that we are telling our Python system that I have a for loop. Go inside, in basically does that, go inside the fruits, which is this array here. Read the first element of this array, which is apple. Assign that apple to the variable x, and then print m. Make sense? So what this loop is doing in this one line, it's actually performing 4 main operations. First, it's reading a list. Second, it's reading each element of a list. Third, it's assigning the first element to the variable x. Then when it prints, it goes back and checks if there is another next element. If there is a next element, it assigns the next element to x again, overriding the previous value. And then we print it. Then it again goes back and prints the third element. Then if there is a third element, it assigns the third element to the x. Prints it, goes back and says, hey, there's no more element. So that's the fourth thing. This says there's no more element here. So the condition becomes false and it exists. So just using this one line of code, you can traverse through a list that can contain 1,000 to 1,000,000 data. By just using one line of code, you can loop through a list that can contain 1,000,000 lines of code. This is how powerful the loop for with the combination of in is. For is a keyword, in is a keyword. Okay, so this using this for in loop, we can traverse any array, similarly set, similarly tuples, and whatnot. Okay, so same way you can loop through a string as well. You can say for x or any other variable name. This doesn't have to be x actually. You can give any variable name. In, for example, this string. This is a direct string, or you can save a string in the variable and write a variable name here. You can, what this will do, again same thing. Go inside the string, read the first character, assign it to x, print it. Now read the second character, assign it to x, print it. Now read the third character, assign it to x, print it, until the last character. Once you reach the last character, loop ends, comes back. Same way, we also have a break, means that if you want to abruptly break a statement, you can use this, or break a loop, you can use this break statement. Now breaks makes more sense when you have for in loop. So for example, you have a list that can contain 2000 elements, but you want to find a particular element, and once you have found it, it's no longer no further point to reiterate or loop through all other remaining elements. Okay, so that's why we use a break statement. So for example, I have a 2000 elements of a list. Okay, so I have a list that contains 2000 elements. Better way to rephrase it. Okay, so I have a list that contains 2000 elements. I want to find a banana from those 2000 words list, and once I've found it, I want to break it. I don't want to go further. So for example, banana exists at second index. If you don't break it, this will go for 2000 times. The loop will run for 2000 times unnecessarily, however, because the banana exists on the second index directly. So breaking it will ensure that our code runs fast. That's why this is there. So we say, hey, for in fruits, read the first element from the fruits, assign it to x, print it. If this first is equals to banana, break, stop the loop. If it is not, condition is false, loop will continue. Go again into the fruits, read the second element, assign it to the x. Print the x. If the second index, now whatever the second item we found, is it banana? Condition true, break. Break means stop the execution flow. It comes out of the loop, and after banana, the loop doesn't execute. So that's what the break does. Similarly in while as well as in loops. Okay, that makes sense. Perfect. So this concludes this session. I try to complete in 1 hour Python, and I hope you understand as much as you can. If you have enjoyed up till this point, please leave a comment. What you like, what you didn't like, what you want to learn next in Python. I am planning to make more detailed tutorials about this as well. So don't worry. If you are into Python, just leave a comment, and that will let me know that you want to learn functions in Python, OOP in Python, and more specifically NumPy, Pandas, the Django's, all these tutorials I have in plan, but I need your feedback. So please do give me feedback. Subscribe the channel if you haven't done so that you can follow along for the next tutorials. This is Dr. Zeeshan signing off.